how we have undergone the error decoding. So using various steps we discussed, and some of the model problems we discussed. And coming to the module 2, here we discuss the cyclic codes. The cyclic codes is a sort of linear block codes. This is a part of linear block codes. You can say this is a subtype of linear block code, which obeys the linearity property. So that's why I'm telling you that this is a like subtype of linear block codes because it obeys linearity property. Coming to the cyclic code, here you can see this is a subtype of linear block code that obey the following properties. So in the module we discussed that the linear block codes obeys linearity property. What we said there, the modular 2 addition of any two code words is equal to the third code word in the same sequence. So coming to the linearity property, our cyclic code also obeys the same linearity property, where the modular 2 addition of any two code words, because once the encoding process is over, the sequence consists of multiple number of code words. The code word sequence consists of a group of code words. So if you take the modular 2 addition of, or you can say the XOR of any two code words, that will lead to the third code word in the same sequence. For example, the sequence consists of some m number of code words. If you take any XOR of any two code words, then it will provide you the third code word in the same sequence. Okay, that is linearity property. And so the cyclic code obeys linearity property, and second one is it also obeys the cyclic property. So what is cyclic property? This is the new one. So here if you discuss if there is any shift in the code word, if there is any shift in the code word, either right shift or left shift, it results in the generation of another code word. What is cyclic property? If there is any shift in the code word, so they can, what is the size of code word? Already you know it is a n-bit code word. The length is n bits, consisting of k number of message bits and r number of check bits. Okay, k number of message bits and r number of check bits. So that is code word actually. So if there is any shift in the code word, if you take either the left shift or right shift, it results in the generation of another code word. It results in the generation of another code word. Now, so either you can take a single bit left shift or right shift, or you can take multiple number of left shifts or right shifts. For example, if you undergo n bit right shift or n bit left shift, where n is the size of the code word, then it results in the same code word. So if you if you continuously go on shifting the data by n number of bits, it will provide you the original code word. For example, let us assume the code word B, capital X suffix n. What is code n? N is a code word length. Consists of a following bit order as x0, x1, x2, x3 up to so on xn minus 1. Then the code word polynomial is represented as x of p is equal to, so this is a code word polynomial for the code word x suffix small n. So x of p is equal to x0 plus x1 p power 1. Here you can see the order where x0 is the LSB bit and xn minus 1 is the MSB bit. So x0 plus x1 p power 1 plus x2 p square plus up to so on. What is the MSB bit? xn minus 1 p power ms1. So this is the code word polynomial of the code word having the bit order as x0, x1 up to so on xn minus 1. Because code word is of length xn, where already I told you x0 is the LSB bit and xn minus 1 is the MSB bit. Okay. Now, for example, if you right shift the code word sequence, here this is the original bit order. If we are intended to move the bit order towards right side. Okay, if you undergo shift for one bit, then the one bit right shift code word sequence consists of bit order as here this MSB bit will comes first and the last bit will be now the MSB bit will be XN. Okay, so XN minus 2 because it is right shifted. So once you right shift the data, this XN minus 1 will come first and the order will be XN minus 1, X0, X1, X2 up to so on. What is the last bit? Xn minus 2. Then the one bit right shifted forward polynomial will be x dash of p is xn minus 1 plus, because here now the LSB bit will be xn minus 1 because we have right shifted one bit. So LSB bit is xn minus 1 plus x0 p power 1 plus x1 p square plus so on plus xn minus 2 p power n minus 1. Similarly, if you undergo 2-bit right shifts, okay, if you right shift 2 bits, if you right shift, then the code word sequence consists of bit order as this xn minus 2 will come first. Okay, so xn minus 2 will be the LSB bit now. Next xn minus 1, x0, x1. And let us suppose continue on till the last bit will be xn minus 3. Okay, this is the MSB bit. Then the 2-bit right shifted code word. Okay, 2-bit right shifted code word polynomial will be x double dash of p. Here double dash represents that we have right shifted 2 bits. So it is equal to xn minus 2 plus xn minus 1 into p power 1 plus x0 into p square plus x1 into p cube plus so on xn minus 3 into p power n minus 1. Okay, so this is the 2-bit right shifted forward polynomial. Now, for example, if you right shift the code word sequence by an amount of n number of bits, if you right shift n number of bits. Similarly, if you go on this process, you continue by n number of right shifts, then you will get the original bit series. So, what is the original bit series? X0, X1 up to so on, Xn minus 1. Okay, and it possesses the polynomial, same polynomial as the original order. That is X0. X0 is the LSB bit. X1 p power 1, X2 p square plus X cube p cube plus so on plus Xn minus 1 into p power n minus 1. Okay, this is the polynomial based on the original bit series. Now multiply x of p with p. Okay, multiply x of p with p and add to x dash of p. So p into x of p, x or x dash of p. Okay, so p into x of p, x or x dash of p. So it will be p into what is x of p? X of p is original bit sequence order. That is x0 plus x1 p power 1 plus x2 p square plus so on plus xn minus 1 into p power n minus 1. X or x dash of p. What is x dash of p? Xn minus 1. You can see in the last slide. What is x dash of p? It is a 1-bit right shifted forward sequence. That is xn minus 1 plus x0 p power 1. Please substitute this x dash of p in this equation. So that is xn minus 1 plus x0 p power 1 plus x1 p square plus so on plus xn minus 2 into p power n minus 1. So it is equal to, now take the XOR of, you can take p power 1 as common. So if you take p power 1 as common, here you have p into x naught and here also you have p into x naught. So take p power 1 as common. So it will be, or else you please first step is please multiply it with p. So then you will get x naught p power 1 plus x1 p square plus x2 p cube plus so on plus xn minus 1 into p power n. XOR xn minus 1 plus x naught p power 1 plus x1 p square plus so on plus xn minus 2 into p power n minus 1. Now let us take p power 1 as common. Okay. So if you take p power 1 as common, it will be x naught XOR x naught. Okay. Plus if you take p square as common, it will be x1 XOR x1. Plus take p2 as common, it will have x2 XOR x2 plus so on plus p power n minus 1 if you take common. Here actually for p power n minus 1 the constant coefficient you can say variable value is for p power 1 polynomial the coefficient value constant value is xn minus 2. So xn minus 2 here also you have xn minus 2. So xn minus 2 XOR xn minus 2 into p power n minus 1 plus what are the leftover parameters? Xn minus 1 into p power n plus xn minus 1. Here the leftover value is xn minus 1. Now what is p into x of p XOR x dash of p? It is equal to, what is XOR x naught XOR x naught? It is 0. Okay, what is x naught XOR x naught? So if you take the XOR of same values, the output is 0. So x naught XOR x naught is 0. And similarly x1 XOR x1 same values, if you take the XOR, it will be 0. Here also x2 XOR x2, so 0. So similarly the modular to addition of any two same values will lead to 0. So that's why all these values will be 0. So 0 into p power n minus 1 will be 0 only. So all these values leads to 0 except xn minus 1 into p power n plus xn minus 1. So what is this? Xn minus 1 into p power n plus xn minus 1. So finally, if you take xn minus 1 as common, so if you take xn minus 1 as common, you will get p power n plus 1. So finally, p into x of p XOR x dash of p. How much you have p? Xn minus 1 into p power n plus 1. So these are the three properties of cyclic codes. First property is linearity property. So this is same as linear block code. And the second property is if there is any shift in the code word, it results in the generation of another code word in the same sequence. So that can be left shift, right shift. If you undergo for n number of, if you undergo for the n number of bits, then you will get the original code word. Okay. And third property is a relation. That is p into x of p XOR x dash of p is xn minus 1 into p power n plus 1. So in the examination, they may ask you to prove this relation for the cyclic codes. Then just you have to assume what is x of p, the original bit order, and then get the x dash of p for one bit right shift. Take the XOR of p into x of p with the x dash of p, then you will get xn minus 1 into multiplied by p power n plus 1. Okay. Now, so this relation, like they will in the examination, they will ask you to prove this relation. Now let us generate a polynomial. So let us assume the generated polynomial g of p be 1 plus g power 1 into p power 1 plus again g1, g2, g up to so on g r minus 1 are the constants for the polynomial factors. Okay, so 1 plus g p power 1 plus sorry, yeah, this is not g power g1. So g of p is 1 plus g1 p power 1 plus g2 p square plus so on plus g r minus 1 p power r minus 1 plus p power r. Okay, this is a generated polynomial. So let us assume this. Now, here you will get in the cyclic course especially in the encoding process. So while doing problems, they will ask you to generate the code words, generate the code words using non-systematic procedure. So they will ask you a question like generate the code word using non-systematic procedure under. Okay. So then you will be given with a message polynomial and you will be given with a generated polynomial. Multiply that two to get the code word using non-systematic procedure. So what is the generation of non-systematic code word? Just multiply the given message polynomial with the generated polynomial. For example, if the message is not given in the polynomial form, uh, they will ask you to generate the code word using non-systematic procedure for all combinations of message bits under. For example, if the code is 7, 4 code, then it is you like to correlate this with n, k. So because k is 4 here, number of message bits are 4. So you will get total of 16 combinations. Already I told you that is 0002 4 months. Okay, so then the code word will be obtained as take each and every combination of message bits. First combination is 0000 and based on the LSB bit and MSB bit, write it in the polynomial form. Okay, so already you know how to write it in the polynomial form based on the like MSB bit or LSB bit. Here x0 is the LSB bit and n minus 1 is the LSB bit. Then MSB bit into p power. For example, if it is a 4 bit, message bit is a 4 bit, then you should start from PQ. Okay, PQ plus P square plus P power 1 plus P naught. Okay, P power 0, right? P power 0 is 1. Okay, so like that you should write the polynomial for the message, corresponding message encoded data. So, message polynomial multiplied by the generated polynomial. What is g of p? In the examination, g of p will be given to you. So, message polynomial multiplied by the generated polynomial provides you the code word using the non-systematic procedure. Okay, so what is x of p? M of p into g of p. The message polynomial multiplied by generated polynomial gives you the code word using the non-systematic procedure. Okay, please remember these equations so that you can easily solve the problems. And second model of problems you get. So you will be asked to generate the code word using systematic procedure. Generate the code word using systematic procedure. Here it will follow 3 steps. Here it follows 3 steps. Multiply the message polynomial. Multiply the message polynomial with p power n minus k. So how can you generate the code word using systematic procedure? First step is multiply the message polynomial with p power n minus k. For example, once again consider 7, 4 code. So 7 minus 4 is 3. 7 minus 4 is 3. So PQ. multiply the message polynomial with p cube. So p cube into the corresponding message polynomial. Okay. So now then divide. What is the second step? Divide the shifted message polynomial. So that is p power r into m of p. P power r into m of p. This is the first step. Divided by g of p. So you will be given the generator polynomial and message polynomial. Or a hint will be given for message polynomial. Or they will be given with 1101 for a 4-bit data, 4-bit message data. They will give you the message combination as 1101. Further, you have to write the message in the polynomial form and multiply it with p power r. Okay, so p power r into m of p, divide it with g of p. Divide it with g of p. Then you will get a reminder. So once you multiply it with p power r, p power r into m of p, and divide it with g of p, then you will get a reminder c of p. Okay, for example, you assume that reminder as some c of p. So p power r into m of p divided by, so in equation form I have written you like p power r into m of p divided by g of p. It is equal to, so if we have some quotient, so take the quotient as p of p plus c of p is a reminder. What is c of p? It is a reminder divided by g of p, because you have divided it with g of p. So C of P is a reminder which is nothing but the check bits. So that reminder is nothing but the check bits. Okay. So the obtained reminder C of P is in check bit polynomial. So obtained reminder C of P is a check bit polynomial. Now add the reminder polynomial C of P. Okay, then add the reminder polynomial C of P to the shifted message polynomial. So what is the shifted message polynomial? P power r into m of p. So p power r into m of p XOR C of p. That will be our code word. So that will be our code word using the systematic procedure. So at any cost, if you make use of the systematic procedure or non-systematic procedure, okay, so you will generate the code word, but using the non-systematic procedure, just directly multiply the message polynomial with generator polynomial. So you will get the code word. In the case of systematic procedure, first multiply the message polynomial with p power r, okay, then divide it with g of t. So you will get some reminder. So equations you have tried in the form using the polynomial form. So in the polynomial form only you have to divide. So that's why I mentioned m of p. Of p represents the the thing in polynomial form. The message as well as the generator. Both are in the not in the matrix form. They are in the polynomial form. Next, as a reminder, you get check bit polynomial. So that will be our added to the p power r into m of p. So here also addition will be in the XOR addition. So that is message bits followed by check bits. It will be our code word. Okay. So now we can discuss some of the problems related to the generation of code words using systematic and non-systematic processes. So you can see in the PDF I have mentioned you. You can see it directly in the PDF. Okay, here you can see. in the same example, we have, I will tell you the procedure for doing the using systematic and non-systematic processes. Here, what is the question? Please see carefully. The generated polynomial for a 7 comma 4 cyclic code is generated polynomial for a 7 comma 4 cyclic code is g of p is equal to 1 plus p cube. This is the generated polynomial given here. Now, can you tell me what is the LSP bit? LSP bit is 1. What is the MSP bit? Is also 1 because the constant 1 into p cube. So constant is 1. The coefficient is 1. And the LSP bit is also 1. And can anyone of you tell me what is the generated matrix here? It is 1, 0, 1, 1. Because p cube coefficient will be MSP bit and LSP bit will be p power 0 coefficient. So 1, p square value is 0. So here I have written that p square value is coefficient is 0 and p power 1 is 1 and p power 0 we have constant of 1. So 1, 0, double 1 is the generated matrix. Okay, leave it. Because but here using systematic or non-systematic procedures we need it in the polynomial form only. So there is no need to reconvert the generated polynomial in the form of bits. So మీకు polynomial formula కావాలమ్మా. So ఇలా ఉంచేసుకోండి equation. Okay. Now determine the systematic and non-systematic code vector for a message polynomial 0, 1, 0, 1 and 1, 0, 1, 0. Now here they have given you the message polynomial. ఈ particular combinations కి చేయండి అని చెప్పారు. But sometimes they may not provide you the message polynomial. So they will directly ask you to calculate the code word using systematic procedure and that. For n comma 4, then you have to do for 16 combinations. So it will be for higher marks. For example, if it is given for only very less mark, 4 marks to each one day, you only take two combinations. Okay, take two combinations of message polynomial and generated polynomial will be given in the question. So for less marks, they will provide you the message bits. Otherwise, if it is given for more number of marks, you have to do it for all combinations of message bits, starting from 0, 0, 0, 0 to 1, 1, 1, 1 to 2 power 4. Because 4 number of message bits are there, so 16 combinations will be there. In the question, they have given you two combinations. So 0, 1, 0, 1 and 1, 0, 1, 0. Now let us start with the first message polynomial. First we are doing using non-systematic procedure. In the PPT, if you see what is a non-systematic procedure, just multiply message with generated polynomial, you will get a code word. Okay, now here you can see 0, 1, 0, 1. So LSB bit is p power 0 coefficient and MSB bit is p power n minus 1. Actually here it is k minus 1 because k bit message bits are there. So k minus 1 ante p cube. So for p cube the coefficient is 0 and for p square the coefficient is 1. For p power 1 the coefficient is 0 and p power 0 the coefficient is 1. So 0, 1, 0, 1. So it will be p power 0, p power 1, p square, p cube. Now what is the message polynomial form for 0, 1, 0, 1? P square plus 1. So this is m of p. So what it may be given to you. So generated polynomial it may be given from MSB to LSB or LSB to MSB. But rearrange the equation in such a way that it is from MSB to LSB so that it will be convenient to you while representing the code word. అంటే మీకు ఎలా ఇచ్చినా కూడా మీరు ఎలా రిప్రజెంట్ చేసుకోవాలి p q plus p plus 1. Okay, that is g of p and m of p is p square plus 1. Now using non-systematic procedure, what is the code word? X of p is equal to m of p into g of p. So m of p is p square plus 1. G of p is p cube plus p plus 1. Please multiply these two. That is enough. So if you multiply, p p square into p cube. So if the base is same, powers gets added. So p power 5. Next p square into p. So it will be p cube. Next p square into 1. So directly p square. And p cube into 1. So p cube plus p plus 1. Actually here you have p cube plus p cube. Please remember this addition is not the normal addition. This is the XOR addition. So here you have p cube XOR p cube. So what is the XOR of same data? It will be 0. So it's not 2p cube. It is 0. Okay. So p power 5 plus p square plus p plus 1. Now please rearrange the values in such a way that and it will be in the question it is given as n minus 1 and 10. So we coefficient p power 6 నుంచి రాసుకోవాలి because it is a 7-bit code word. Write the coefficient from 7 minus 1 power అంటే p power 6 నుంచి రాసుకోవాలి. So do you have any coefficient from p power 6? No. అందుకనే 0 పెట్టుకున్నాను. So 0 into p power 6 plus do you have any coefficient from p power 5? Yes. So 1 into p power 5 plus so on that is 0 into p power 4 plus 0 into p cube plus p square plus p plus 1. So for p cube it is 0 and p power 4 it is a 0. Now take only the coefficient bits. That's our code word. In the form of bits. In the form of polynomial it is only p power 5 3 plus p square plus p plus 1. So x of p is 0 1 double 0 triple 1. So this is the what is the how will be the code word same procedure is applied 1010. So 1010 అంటే p power 0 p power 1 p square p cube. So p cube plus p వస్తుంది. So multiply that with generator polynomial. So you get some code word x of p. So similarly systematic procedure what you studied. First is multiply versus polynomial with p power r, where r is n minus k. So divide by g of p. Take that remainder and add to the versus combination. It gives you the code word. Okay. So only 3 steps are there here. So let us go through the systematic procedure. So p power r into m of p. What is the first step? Multiply the versus polynomial with p power r. So r is 7 minus 4. So 3. So p into versus polynomial into my 1. So this p square plus 1 and 80. 0 1 0 1. What is the first combination? First combination is 0 1 0 1. So it is p square plus 1. So p square plus 1 into p cube. Because p power r kabatti r is 3 here. So p cube into p square that is p power 5 and p cube into 1 that is p cube. Just we multiply. Okay. So what is the second step? First step is multiply the versus polynomial with p power r. Second step is divide the p power r into m of p by generator polynomial. What is the generator polynomial? In the question, generator polynomial is given as p cube plus p plus 1. I told you rearrange the powers in the decreasing order. So p cube plus p plus 1. Take g of p and divide p power r into m of p by g of p. So p power 5 plus 0 into p power 4 plus p cube plus 0 into p square because no coefficient for p square and no coefficient for p power 1 plus 0 because p square p power 1 p power 0 ki coefficients levu అందుకని 0 పెట్టుకున్నాను and p power 4 కూడా coefficient లేదు. So that's why I kept as p power 4. Now take multiplication. So p cube, how you get p power 5 using p cube? Take p square. So multiply it with p square. So p square into p cube will be p power 5 plus p square into p will be p cube plus p square into 1 will be p square. Just this is like normal division, except that cancelling, take the modulo 2 addition. Okay. So if it were p power 5 extra p power 5, same values kabatti you will get 0. And this is already 0. 0 into p power 4 is 0. Leave it. And p cube XOR p cube, it is 0. And 0 into p square. So this is of no value. So we have only p square. So take that down. So p square plus 0 or 0 into p power 1 plus 0 into p power 0. So what is the remainder? Remainder is 1, 0, 0. Why I am writing the remainder as a 3 bits? Why not 4 bits? Because the here check bits are only 3. That is 7 minus 4. Check bits 3 kabatti power bit maximum 2 ante ravali. Okay. So p square plus p power 1 plus p power 0. Take the respective coefficients and write it as a check bit polynomial. Check bit. Okay. So it will be 1, 0, 0. Because the coefficient of p square will be the MSB. So 1, 0, 0. So you may get it doubt why C of t is only 3 bits. Because here it is given in the question, it is given as 7, 4 code. So that's it. Check bits are 3 only. The remainder bits will 3 bits. So power will be only from p square. 3 minus 1. That is 2. Power will be only from r minus 1. Check bits. Now these message bits are followed by check bits to get the code, right? And a 0101 is the original message bit, followed by check bits is a reminder 100. So that is our code. We are using the which procedure? Systematic procedure. So if it is not systematic procedure, just we multiply the message and generated polynomial. You will get it as you will take the you will multiply 3 steps you will follow. First thing is take the message polynomial, multiply it with p power r, and in the second step divide it with g of p, and you will get the remainder. Take the remainder bits and write in the same format. A format lo rastaru. A number of message bits followed by r number of check bits. That is our code word X using the systematic procedure. Okay. Now this is the and the same will be performed for second combination. What is the second combination? 1 0 1 0. So it is p power 0 coefficient, p power 1 p square p cube, and p cube plus p square. Now what is the first step? Once again follow the same procedure. Multiply it with p cube. You will get p power 6 plus p power 4. Get p cube plus p plus 1. So if you multiply with p cube, you will get p power 6. You can cancel p power 6. So p power 6 plus p cube into p, that is p power 4 plus p cube into 1, so p cube. So here p power 6 and p power 4 gets cancelled. The remainder, it has only one remainder, that is, here you will get only p cube plus 0 into p square plus 0 into p power 1 plus 0. Here actually, while first multiplication with p cube, the remainder is p cube. But you cannot take the p cube as a remainder because the check bits are only 3 bits. The power should start from 2. So అందుకని చెప్పి మళ్ళీ డివిజన్ కి పాసిబిలిటీ కూడా ఉంది. ఇక్కడ p cube ఉంది, ఇక్కడ కూడా p cube ఉంది. So you can take 1. So 1 into p cube, that is p cube plus p plus 1. So here p cube XOR p cube gets cancelled and you will get p power 1 plus 1. Coefficient 80, no coefficient, so 0. Remainder will be 0 1 1. Remainder will be 0 1 1. addition procedure is almost all same to the normal addition, except that here we are writing in the polynomial form. You can say that the code word is a combination of 4 message bits followed by R check bits. Here check bits are nothing but the remainder bits. That is the 0, 1, 1. So this model of problems are very important for examination. Last semester we seriously question వచ్చింది కూడా. Using the systematic and non-systematic serious. Okay, so but they did not mention the present polynomials. So we told them to take any 2 examples. If it is given for less number of marks, but if it is given for almost 16 marks teacher ante, then we have any bits ఉంటాయి మెసేజ్ బిట్స్ 4 ఉంటాయి కాబట్టి 16 కాంబినేషన్స్ కి చేయాల్సిందే అంటే 00000 to 4 మార్క్స్ బట్ సేమ్ క్వశ్చన్ 16 మార్క్స్ కి ఇచ్చే పాసిబిలిటీ ఉండదు సో యూ విల్ బి గివెన్ విత్ 2 అంటే లేదు అంటే టేక్ 2 కాంబినేషన్స్ ఆఫ్ మెసేజ్ పోలినామియల్స్ and మీకే చాయిస్ ఇస్తారు they will provide you the corresponding combinations like this. Matrix, okay, calculation of generator matrix for systematic and non-systematic. We discuss in the next classes. So, we can finish our module 2. Okay, we can finish our module 2 and then we can move to the next module, that is the convolutional code. Okay. So any doubts? Okay, please wait, I will take the attendance. Okay, ma, thank you and happy Pongal to everyone. Now you can leave the class.